Hey everyone, these are our Can You Do solutions for 44, lesson 44. Some of these I don't think that you really need an explanation, so I'm not going to give much of one, but there is one problem that I think that you might want a little bit of explanation for. So you can see number 1 on your screen. There's really nothing here to explain. The only thing that I want to highlight is that I have this underlined and bolded because when you do your residuals, you want to make sure that you include the units. Other than that, I think that number 1's pretty straightforward. Number 2, would it be appropriate to use the regression line to predict y from x? So we've talked about this before. We want to use the prompt as best we can to answer our questions. So you do have sentence frames that will help you through answering questions like this. But this is slightly different than the sentence frame. What I have written is, it would not be appropriate to use the regression line to predict y from x because there is an obvious leftover pattern in the residual plot. So I believe that that hits everything that our sentence frames do, but it's just worded slightly differently. Number 3, use your calculator's regression function to find the equation of the least squares regression line. So be careful that on this one, you not only have your regression line, but you also have defined your variables. And then what I've added in here, sorry, I'm going to adjust because this is really blurry. Maybe it's not showing up as blurry to you, but it looks really blurry to me. This was something that was commonly missed on quiz 43. When you define your variables, make sure that you note that y hat is your predicted y value. So lots of you guys said, like on your quiz, where x is lean body mass and y is metabolic rate, or y hat is metabolic rate, y hat is your predicted metabolic rate. So anytime you're asked for a regression line, you always write the line and define the variables. You will miss points on your AP exam if you just write the equation without defining your variables. B is straightforward, just like number 1. We calculate our residual, we interpret it. I think that one of the other things that I wanted to highlight is that on this page, you don't put a negative 13 for your residual because the statement 13 cubic feet less, this less takes over the negative. So here, 85 calories more than expected. Use your calculator to make a residual plot. You don't have to put this residual plot on there. I have put it on. I have put it on the key because I want you to know whether or not the residual plot you have in your calculator is accurate. So I have it on here just for your reference. Aside from this point, I think that this is a residual plot that is randomly scattered. Once again, I haven't quite followed our sentence frames on this to a T, but I have all of the elements, and it's pretty close to what I have provided in the notes for you. So I believe that a linear model is appropriate for this data because there is no leftover pattern in the residual plot. And I did a semicolon just to state the points appear to be randomly scattered. So you don't need to say both of these. You don't need to say there's no leftover pattern and then say that it's randomly scattered because they're both the same thing. But I thought that my response sounded better and more knowledgeable by writing it that way. You don't have to exclude this point to decide. It just was easier for me to ignore it when I was deciding, is that random scatter or not random scatter. Then the last point, or the last problem, is identify the residual. Identify the point that has the largest residual, and then explain what the value means. So when they say explain what the value means in context, what they're asking you to do is interpret. So they're just asking you to interpret the residual, which is what we did up here and on number 1. To find the largest residual, I knew that this was the largest because from this line, remember this 0 line means that the predicted value and the actual value were exactly the same. So you very rarely have points on 0 because we very rarely have a prediction that's exactly the same as the actual value. We have ones that are real close, like that guy's real close. But whatever point is farthest away from this 0 line is going to be the largest residual. So this one is the farthest away, farther away than any other point. So to find this using your calculator, this is why I decided to make videos for this one. So if I go into my graph, here's my residual plot. And if I want to know what the coordinates of this point are, all I need to do is hit this trace button. So trace is your fourth top button, fourth over top. And your point, your like flashing X might end up somewhere else. So just hit your arrows left or right. Like if I hit my arrow left, it won't let me go any more left. So then I tried hitting right and it allowed me to go up to that residual, and it gives you the values down here at the bottom. So this is telling me that my X value was 42 and my residual value was 207.7436. So that is how I got the residual, the coordinates for that residual. You could have also tried to just estimate it. You could have also just like tried to drag this down. And now you know that that's about X of 42. So you come up here, you have two 42s, but you want the one that is farther away, so it would be that one. And then you could just calculate the residual like we did here. You don't have to use your calculator. Your calculator just makes it quicker. Let me say that one more time. If you don't need to hear it, just fast forward. If you were going to do this by hand, you find the X coordinate on your residual plot. You match that up to what the data is, the actual point from the problem. There were two. You chose the one that had a bigger Y hat, or sorry, a bigger Y, because that would have a bigger residual. And then to find 208, you would need to go through this process to find the predicted value. So really, if you just use your calculator's trace function, this part of this problem becomes much easier. Then lastly is just the interpretation of that residual. So the actual metabolic rate is 208 calories more than expected based on lean body mass. So that's it for Can You Do 44. I'm going to have to, just for your reference, this Can You Do and the Can You Do before it have been shorter. These Can You Do's have only been 2 pages, and normally your Can You Do's are much longer than that. And part of the reason why is because I've been building those questions into the lessons that are labeled as a quiz. So one thing to note is that they're only labeled as a quiz because that's the only way I can get it to show you the correct answer after you submit. The only option in Canvas is to call it a quiz. Otherwise, I wouldn't call it a quiz. Number 2, the score does not matter. If you get 25 out of 50, that doesn't mean you get 25 out of 50 on your grade. However, you need to understand why you got wrong what you got wrong. The interpretations, the fill in the blanks, I know that those are annoying to a lot of you guys, but they do help. I do think that it helps you realize that the AP board is looking for very specific things. So if you're missing little things like spelling here and there on the interpretations, I wouldn't let that bother you. But if you just flat out don't know how to do the problems, then that is a problem. And if you're not doing them, many of you are not doing those practice problems. You are missing a lot of information for the lesson. And I'll probably say this in the next lesson I film, so if you've already heard this, hopefully you've stopped playing the video by now. But yeah, that's it for your Can You Do. If you have any questions, as usual, let me know. Love you guys.